Venkatnarayan, a first year student at Sri Venkateshwara College of Engineering, Bangalore. Course title Chemistry. Topic Corrosion and its types. Let's get started. What is corrosion? Corrosion can be defined as the destruction or deterioration or loss of metal or alloys by the surrounding environment through chemical or electrochemical reactions. Example, rusting of iron, a reddish brown scale formation on iron objects, and a green scale formed on copper vessels are the example for corrosion. Corrosion may occur either in the dry environment or in aqueous medium. The former is called dry corrosion and the latter is called as wet corrosion. What is dry corrosion? Dry corrosion involves the direct attack of metals by dry gases, mainly through chemical reactions. It occurs by direct attack of atmospheric gases such as oxygen, hydrogen, sulfide, halogens and sulfur dioxide on the metal forming oxide layer. Example, the attack of dry air or oxygen on a metal to form an oxide layer over the surface. What is wet corrosion? Wet corrosion involves reaction in aqueous solution medium. The conducting surface of the metal undergoes an electrochemical reaction with the moisture and oxygen present in the atmosphere. Example, rusting of iron. Electrochemical theory of corrosion. Taking iron as an example, according to electrochemical theory of corrosion, when a metal like iron is exposed to corrosive environment, it forms numerous small galvanic cells with anodic and cathodic regions. At the anodic region, oxidation occurs, converting the metal into iron and releasing electrons leading to corrosion. In the cathodic region, reduction occurs, but since the metal cannot be further be reduced, the metal atoms there remains unaffected by the cathodic reaction. At anode, oxidation takes place in which the metal atoms are converted into their ions, liberating electrons. Fe forms Fe2 plus 2 electrons. At cathode, the reaction is based on the nature of environment. In the absence of oxygen, that is liberation of hydrogen in acidic medium, 2H plus 2 electrons forms H2. In neutral or alkaline medium, 2H2O plus 2 electrons forms 2OH minus plus H2. In presence of oxygen, that is absorption of oxygen in acidic medium, 4H plus O2 plus 4 electrons forms 2H2O. In neutral or alkaline medium, 2H2O plus O2 plus 4 electrons forms 4OH minus. So Fe2 plus liberated at the anode reacts with hydroxide ions liberated at cathode to form ferrous hydroxide. Fe2 plus 2OH minus forms FeOH2. 4FeOH2 plus O2 plus 2H2O forms 2Fe2O3 3H2O. Hydrated ferric oxide, that is also called as rust. Moving on to types of corrosion. Differential metal corrosion. Differential metal corrosion, also known as dissimilar metal corrosion or galvanic corrosion, which occurs when two different metals are in contact with each other in the presence of an electrolyte, such as moisture or salt water. In this electrochemical process, one metal acts as the anode, that is the more reactive metal, and undergoes corrosion, while the other metal serves as cathode and remains relatively unaffected. Differential aerial corrosion. Differential aerial corrosion, also known as atmospheric corrosion or selective corrosion. refers to uneven degradation of metals due to exposure to the atmosphere. This type of corrosion occurs when different areas of metal surface are subjected to varying environmental conditions, leading to differential rates of corrosion across the surface. Other type of corrosion. Uniform corrosion. Uniform corrosion occurs evenly across the surface, leading to gradual loss of material. Factors such as exposure to corrosive environments and material composition influence the rate of uniform corrosion. Pitting corrosion. Pitting corrosion involves the formation of localized pits on the material surface. These pits can penetrate deep into the material, leading to severe structural damage even with minimal surface signs. Galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of electrolyte. This leads to more active metal corroding while the less active metal is protected. So I hope you all have got an idea about the corrosion and its types. I would like to conclude my video by saying thank you, goodbye, have a nice day.